Hello, today we are going to talk about scientific notation. We are going to discuss what it is, why it's important, how to convert into scientific notation, and how to convert out of scientific notation. What it is. It can be written in a general form as a number n times 10 to an exponent e. So an example of what this looks like. N is any number between 1 and 10, and it includes 1. So that would be this number here. And the e is any whole number written as an exponent. So what are some examples of things that are and are not scientific notation? In our first example, we have 5 times 10 to the negative 9th as an exponent. This is an example of scientific notation. Here's another example of scientific notation. 2.36 times 10 to the 6th. Some things that are not scientific notation. 5 times 10. There's no exponent above the 10, so that indicates that it is not scientific notation. Or 63.2 times 10 to the third. Even though it's a number times 10 to the third, this number is not between 1 and 10. So why would we use scientific notation? We use scientific notation anytime you're dealing with very large and very small numbers. For example, the speed of light is 30 million meters per second. That takes up a lot of space to write. So if you were writing this number over and over again in an equation, you would want to take a shortcut and use scientific notation and write 3.0 times 10 to the 8th. It takes up much less space and is much easier to write. So now let's practice converting out of scientific notation. So the first thing we're going to do when we go to convert out of scientific notation is write the first number out front. We're going to rewrite this 3.92. Then we are going to look at the number by the 10, the one that's an exponent. In this case, it is a 2. That's going to tell us we need to move the decimal 2 places. Now, anytime that the exponent is greater than 1, it is going to cause us to move the decimal to the right, meaning the number is going to be bigger. If it is a negative number, which is what we have in the next example, we are going to move it to the left. But in this case, it's a positive 2, so we're going to move the decimal 2 places to the right, 1, 2. So this will be the new location for the decimal to write the number in standard form, so our number is 392. So we took this number, 3.92 times 10 to the second, and converted it into standard form. Now, let's try the same thing, but this time we have a negative number. So we are going to write out our 7.5, and we are going to move the decimal 3 places, and because of this negative, we are going to go to the left instead of the right. 1, 2, 3. And this will be where our decimal will be. Inside of these little loops, we are going to write a 0 for each little loop, and that just holds the place of the values. So we end up with the number 0.0075. Let's go ahead and practice getting into scientific notation. So getting into scientific notation. first thing we are going to do is look at where the decimal currently is. Now in our first number, 3,200, there is not a decimal that is written. But if we were to write a decimal, we would put it right behind this last 0. Now all we have to do is move this decimal until we get it to a place where the number is between 1 and 10. And count how many moves the decimal makes. 1, 2, 3. Now we're going to write that number, 3.2 times 10. How many places did we move it? 1, 2, 3. So we're going to write a 3. And in this case, when we're going into scientific notation, the decimal moved to the left. So in that case, it is going to be positive, because when we go out of scientific notation, we are going to have to move it to the right. So our answer is 3.2 times 10 to the third. Another way you can look at this is 10 times 10 times 10 is a big number. So when this gets written in standard form, it will be a big number. Our next example, we have a number that's less than 1. We're going to count the number of spots we need to move the decimal. 1, 2, 3, 4 to get a number that's between 1 and 10. 6.7 times 10. We moved it to the 1, 2, 3, 4. So 10 to the 4. Now, because this number is a small number, this has to be a negative, so that when we convert back out of scientific notation, we need to move the decimal back to the left. Now, go ahead and try these 4 problems, converting out of scientific notation and converting into scientific notation. Go ahead and pause the video, work these out on a piece of scratch paper, then hit play and I will reveal the answers to you. Okay, let's go ahead and go over these problems quick. So we have 6.99 times 10 to the 4th. We'll write 6.99 10 to the 4th. This number is going to get bigger, so we're going to move to the right. 1, 2, 3, 4. We need to add zeros here. So this becomes 69900, 69,900. Next problem, we have 5.3 times 10 to the negative 4th. Because it is negative, we are going to go to the left. 1, 2, 3, 4. This is where our decimal is going to be. 1, 2, 3. So we end up with the number decimal 0.0053. Now converting into scientific notation. I'm going to move the decimal 2 places, so we get 3.6 times 10. Now we have to look at, do we have a small number less than 1 or a large number? This is a number less than 1, so we're going to have a negative exponent. And we moved it 2 places. Next problem, our decimals here behind all these zeros that represent placeholders. So we're going to start here and go 1, 2, 3, 4, 5. 4.5 times 10, and this is a big number, so it's just going to be to the 5th. The exponent is positive. Now you're ready to go ahead and try your homework problems.